Hi, my name is Jessica Clement, and this is my presentation on the origin of life. So we'll start off with a timeline. Earth formed with the solar system about 4.5 billion years ago. Soon after, the Earth saw the late heavy bombardment, which is just a pretty much constant stream of impacts from comets and asteroids, which lasted between 4.1 and 3.8 billion years ago. And during this time, the oceans and the Earth's crust also formed. So the earliest evidence that we have for life is about 3.5 billion years ago through fossils called stromatolites that were found that are pretty much byproducts of microorganisms. So the definitions for life that we're going to be using, we'll start with Merriam-Webster Dictionary's definition for life, which they define as an organismic state characterized by capacity for metabolism, growth, reaction to stimuli, and reproduction. And the definition that I like is by Erwin Schrödinger, the famous physicist who also did the cat in a box thought experiment. He described life as resisting decaying to disorder and equilibrium. So that has to do with entropy, whereas living system resists entropy, which is disorder. So the conditions for life that we needed on early Earth was obviously the oxidation of the atmosphere, because life as we know it needs oxygen. There was also needed to be atmospheric hydrogen, nitrogen, carbon, and also the metals from the late heavy bombardment. The metals were brought in by comets and asteroids. We also needed high temperatures and an energized atmosphere in order to provide the energy that life needed for its systems. And the atmosphere also needed to be thick enough in order to block out harmful UV rays. So Harold C. Urey was a scientist in the 1920s and 30s who ran experiments in order to prove that these conditions did exist on early Earth, and therefore life could have arisen during that period of time. So Harold Urey, oh, I'm sorry, I got ahead of myself. The primordial soup model was a term first coined by Alexander Oparin in the 1920s, which is the idea that Earth arose in the oceans filled with organic molecules, and it was energized by the lightning and the common asteroid impacts of the late heavy bombardment. So Harold Urey, who we talked about, proved that certain organic molecules could be reproduced given the conditions of early Earth, and he essentially proved Oparin's theory that Earth could have started in this primordial soup kind of environment. So his experiment, Stanley Miller teamed up with Harold Urey in 1952 to reenact early Earth conditions to essentially prove that organic molecules could be created through what they knew was already in the environment. So on the diagram on the right, there is an electrical spark inside of a glass case, which has H2O, CH4, and H3, hydrogen gas, and carbon dioxide. So it's energizing those chemicals, and then there's hot water provided going through. And through this method, they discovered more than 20 amino acids could be synthesized. And they also discovered other organic compounds, such as urea and hydroxy acids. So really similar to the primordial soup model is the deep sea vent model. And essentially, it's about the same, except for instead of at the life starting at the surface of the ocean, it started at the bottom near these hydrothermal vents, which provided oxygen, minerals, carbon dioxide, and energy to the life that was arising during that time. Another reason why scientists think that the deep sea vent model is viable is because the ocean above it provided protection against the heavy impacts coming in during that time. Alright, and a more out there kind of theory, but it's getting a lot of attention lately, is something called panspermia. And what that term means is that life, or the building blocks for life, could be carried via a comet to Earth. And we know through different experiments that spores can be kept alive in space, and these spores are all obviously extremophiles, which are microorganisms that can survive very extreme temperatures, pressures, salinity, etc. So those have been they've been proven to be able to survive space for up to 6 years, and that's the longest experiment that was done. So they could potentially be able to survive longer, but not a lot of experiments have been done about that. But there are a lot of unanswered questions in the origin of life field of study. We have yet to be able to successfully replicate life from non-life. The primordial soup model, the deep space vent model, and the panspermia model offer offer answers as to where life came from, but the question of how life arises from non-life is not definitively answered. So that wraps everything up. Thanks for listening. Have a good one.